Hello there. In this video, we're going to be going over homework 3, or at least my current version of homework 3. The homework you work on may be slightly edited or updated, but I think this video should help a lot, and you should probably watch it. Okay, so the first thing we want to look at are the imports. In this homework, we're importing NumPy for, the ability to work with arrays. Pandas, when you hear pandas, we're importing that as PD, think Excel, so working with things like Excel sheets. We're going to import OS, and we're going to use that in order to read information out of files. So if I were to say, have a file or a folder full of information, OS can tell me all the contents of that folder. And it can do a lot more, but that's what we're going to use it for. And finally, we're going to import matplotlib.pyplot as PLT. And this just allows us to make pretty figures from the data we're working with, which can help us visualize our results and ensure that we're correct. Okay, great. So lines 12 through 21, you don't have to worry too much about it, or in fact 12 through 27. Here we're just defining the student class, and you're going to build a little student made out of that. And once you've built your student, we can access all the information from the class associated with it. So you will put your first name in here, your last name, your email, your UID, and that'll build your student, and I'll do the rest. Okay, so in this homework, I'm going to be showing you example 0 and example 1, I believe. Let's make sure that's the case. Example 0 and example 1. And you know what? Let me run this first cell. I'm going to use Shift-Enter in Spider to run that first cell. So example 0, I'm going to ask you to make a function that can loop through a list and find the numbers that are divisible by n. Let's go ahead and try to make this a little bigger. And for the sake of this homework, I'm going to make the text just a tiny smaller so that we can see all the way up until this 79 character limit, which is a soft limit. Don't worry too much if you go over it. It doesn't break your code. It's just not quote-unquote best practice. Okay, so let's see what this error is. White space. Excuse me while I fix that. Perfect. Okay, so the idea of this homework is to work with loops and arrays, and just things loosely associated with the problems where loops and arrays come up. So an easy one for us is let's implement a naive solution where we're trying to find multiples of n, given a list of values and the n we're interested in. So in our case, our list is going to be 1, 16, 21, 34, etc. Some seemingly random numbers. And what we need is a function that, given that list, can find all of the multiples, or all of the numbers in here that are in fact multiples of 6. So what we're going to do is, in this case, we're going to use a for loop that has an if logic inside of it. So for value in list of values, if our value is divisible by n, or if the modulo gets us a value of 0, we can append that to our list, keeping track of all multiples of n. So what's going to happen is you're going to write the function with this name that takes in these arguments, list of values in n, or in this case is an example, so it'll come pre-written for you. And that function needs to return, you can see where the arguments would be, the correct answer. And if your answer is equal to the correct answer, we'll tell you you're correct, and your student object will have its scores updated. And in this case, for the example, I'm saying you can get 0.2 for just looking at the homework. In example 1, we're going to grab some summary statistics. So whereas the other one used a loop where we grabbed each value in the list of values and checked for this division, here we're going to use arrays. So I'm going to take my data of interest, I'm going to convert it into a NumPy array. I'm going to say my max is the NumPy array. So notice the data of interest was overridden with this new with the new value, which is an array as opposed to the list that was input. And it's going to get the max of that array, the mean of that array, and the standard deviation, and return those in a list. And so here the doc string sort of described what we were supposed to do. And so I'm going to build this function name, return my stats as a list, and here I've got a bunch of different data to check against. So really quickly, you'll notice this mp.random.seed1. This sets the random seed. So if I run this, and then I run this mp.random.random integer, it's going to return a huge amount of data. But it's always going to be the same since the seed was set. So even though it's going to look like random numbers, it'll always be the same if I run this with seed equals 1, then run this. If I run it with seed equals 2, and then run this, it won't match the random numbers from seed equals 1. Or if I run it in multiple instances in a row before I rerun this, it won't match. Just an aside. You probably could have skipped that. So I'm going to build these different data sets, and I'm going to get summary statistics for all of them. And then I'm going to compare them against the correct answers. So my answers versus the answers. And what I'm going to get is I'm going to ask NumPy to check if all of these are close within an absolute tolerance of 0.01. And it's going to, if they're right, tell me I'm right. So let's run this first one. So it says QE0 is correct, which means it added these points to my expected homework score. Let's run the second one. QE1 is correct. So it's going to add these points to my expected homework score. And we can move on. So question 0. It's now your turn. This will not be filled in. Write a function that loops through a list of numbers and returns the square plus 2 for each of them. So here I'm going to be building a loop, and I'm going to be returning a list with the square plus 2. For the next part, notice I haven't checked that yet. Both of these are going to be scored at once. For the next part, I'm going to do the same thing, but I'm going to use NumPy operations to make it a quote-unquote one-liner. So I'm going to make a list of my NumPy array, and since it's a NumPy array, I can broadcast the square and I can broadcast the addition onto each item inside of the array. So it's just a little bit simpler. And then here, let's run these two cells. We're going to check that these two are the same. So np.allClose to check if qMyAnswer from 0 equals qMyAnswer from 1. And I'll just check that qMyAnswer is also equal to the correct answer. So if this is true and this is true, then both of these are correct, and you'll get 2 points added to your expected score. So there we go. We're good to move on. So Q1, write a function that, given a user input, will try to convert the input to an int type, and on exception, if the user has not input an integer value, you should inform them the input was incorrect and re-prompt them. So here you're going to use a while loop until the user gets it correct. So you're going to try to convert their input into an integer, and if a try throws any type of error, your except will try to catch it, and you're going to say except. So if try throws a value error, you can print this off. Otherwise, your except won't catch it here. Now you can do a naked except, where any error period will always be caught, and you'll always execute this line of code. But generally, that's bad practice, and people say not to. So in our case, if it tries to convert it to an int, and it's not able to, it's going to say there was a value error, meaning this input did not work with the int function. And so we're going to get an exception. We're going to tell them it's incorrect, but since we're inside of a while loop, and our int type has not been updated to true, it's still false. So we're going to start assuming that they have not given us an integer, and only when we're able to convert their number to an integer will we change that. But since it's still false, while not false, while not false, so not false is the same as true. So while true, it's always going to execute. While not true, that'll break it. Not true is false. And so once this int type is able to take the value true, we're going to exit the while loop and we'll return the user's input. So let's just look at what would happen. We're going to hit run, and it's going to say, because I wrote this code, it's going to say type an integer here. So you need to have it so that if I type an integer, it says the question is correct. But if I run it and I don't type an integer, let's say I type a string in here, it's going to say incorrect input type, meaning this could not be converted to an integer. Even like 1.5, incorrect input type. So it has to be an integer. There we go. Now in your case, all I really want is that you use this while loop and make it so that the while loop runs until this input is satisfied. And if you want, you can sort of copy the way I've done it, but I don't know if this is the best looking back on it. Anyways, now for homework 3, create a function that thinks of a number and makes you guess it. So think of the guessing game. I'm thinking of a number between 1 and 100, and it's your turn to ask, is it 7? And I'll say it is less than 7. Or you can ask, okay, it's less than 7, is it 0? And I'll say it's greater than 0. Well, you're going to build that function. And again, you'll use a while loop here. Now I'm going to try to not show you the code, because I want you to struggle through this just a little bit and work together as groups to try to figure it out. But when you run it, what you're going to get is, please guess a number. I'm going to guess a number. Let's say I want to guess 5. It's going to say I guessed too high. I'm going to guess 2. I guessed too low, so I'm narrowing it down. Too low. So the number is 4. My number is 4. Q3 is correct. So in your case, what you need to have your function do is when the user is right, have your function return true so that it can ask if type of my answer is true. You know, an easier way to do this would just say if my answer. Let me see if I'm wrong here. There we go. So if my answer, so your function will return true once the while loop is broken, meaning once the user has guessed the right number, you'll get your points. So question 4, this one gets quite a bit more complex. Those were all pretty easy. Question 4 is going to have you working with actual XRD data. Now the first thing you're going to go through is you're going to take a single raw XRD file and you're going to try to find the maximum value in that file, and you're going to normalize your XRD pattern such that that maximum value now has a value of 1 and everything else has been scaled accordingly. So here's the description. You can read through it. But when you run it, essentially you're going to take in an array of XRD signals. So this is going to be n by 2, n representing the number of data points collected, and 2 being the columns, where one of those columns is your 2 theta. That's the column in index 0, or the first column. And the second column, the column in index 1, is going to have your signal amplitude. So when you run this, what you should expect if your function's operating correctly, and here's our first error. So when you get your homework, it's going to be presented in a zip file as opposed to just the .py. When you unzip your zip file, the .py is in its correct directory. The directory is where that file is relative to everything else. In fact, let me pull it up for you. So this is what it's probably going to look like. When you open up homework 3, or when you unzip it, you'll unzip this homework and it'll look like this. You can run homework 3 from here. And so its directory is this set of string, or this string. From here, let's say we want to grab this CSV file. We need to tell our computer to read in xrd1.csv, and it's going to try to read it in from this location. Now week 4 does not have xrd1.csv as a file inside of it. I can set console to my current working directory. Now homeworks 3, week 3, if I come here, that's this. That file is in fact within this directory. So let's run it now. It's going to say Q4 is correct, and it's going to generate a plot for us. Let's go ahead and look at this plot. So this is our XRD pattern, and we can see it's now been normalized such that the maximum value is 1, and everything else has been scaled down accordingly. So that's what you're going to be doing with this first problem. You're going to figure out how to take in that array and normalize it. Now the second problem, you're going to do this across m different arrays. I believe there are 6 of them. When we run this, we can look at what it looks like. This should be the correct output. The array, or rather the XRD signal with the most counts, will be normalized to 1, and then everything will be normalized relative to that signal. And then our next question that I think is probably the hardest part for the XRD ones, is we are supposed to find all of the 2 theta values where there are max peaks, but we're restricted to looking between areas where 2 theta equals 5 and 30. Let's say we didn't want all this extra early stuff here, from 0 to 5. We only want to know locations of peaks all the way through to here. And we've been given way more data. We have up to 42 different signals. Let's just go ahead and run that, and yours should look like this. So if you've got it correct, these red boxes will match up across all the 42 different measurements where their maximum peaks were between 5 and 30. So here, this little brown line, that may be a mistake, but it's saying our maximum peak is right over there. Okay. Now, after working with the XRD data, we have data associated with the usage of a furnace. And it's a furnace that's been running since 1990. And the first thing we're going to do is we're going to take one of the power usage files, saved as a text file. We're going to load it up. We're going to do np.loadText, and you can load text files in multiple ways, but we can use the np.loadText on this one because the text file is formatted very nicely. Let me just show you that formatting very quickly. So it's going to take in file path, and notice file path, it's going to be the directory we're in, so homework 3, but then it's going to add furnace data, and then data, and then the text file. So let's go to the directory we're in, homework 3. Our file path needs to reach into furnace data, because I would need to do that. It needs to reach into data, and then it can grab power usage 1990 213. So that would be this one. And this is the formatting of that text file. So it has a value, and then a new line character, and then a value, and then a new line character, etc. And so this specific formatting can be read in by this np.loadText. Anyways, I think I just showed you the answer to this one. But what we're going to do is we need to make sure that when we load this text, we can get the mean watt usage for the machine at that time. So that'll work just fine, and that's going to execute here. Now the next thing we're going to do is, well, it's not enough to just look at one of those files. You've been asked to go through all of them, all of the old furnace data, and determine essentially how much it's diverged from its original performance. And so what you're going to do is you're going to make a function that receives the entire directory as an argument. So let's look at what that argument would look like. Here's the directory. It's furnace data / data, so it's the directory, and you're going to use os.listdir. So you're going to list that directory, and it's going to list out every single file in that directory. And you're going to iterate over those files, and you're going to find the year, which you'll type in as an integer, and you're going to find the mean power, which you'll type in as a float. So you're going to make this a dictionary. You're going to make a single dictionary that tells you, given a year, what was the mean power consumption. So for each run of this furnace, what was the mean power consumption as a float. Now Q9 then gets a little in the weeds. It says you're considering buying a new furnace, or at least your manager. And the furnace is $7,000. And he has the specs. He says it uses 15 kilowatt hours per run. So to run it for 8 hours, it's going to take 15 kilowatt hours of energy. And he's telling you the cost of energy is projected over the next 15 years to be 25 cents per kilowatt hour. So he's asking you to determine whether or not this furnace should be purchased or whether we should use the old furnace. So I'll leave you to do that. And you're going to go through all the math, and you may or may not use a for loop depending on how you want to implement your solution. And then finally, I just want you to quickly see that NumPy can do all kinds of linear algebra stuff. np.linearalg, go ahead and type that into Google and just see what it can do. And then conveniently, it can extract eigenvalues and eigenvectors, and you'll use that to get your final solution on the homework. So let's say you put in all your code. Once everything runs and all your code is in and each cell says you're correct, if you hit F5, what you should be able to do is type the integer you're supposed to, guess correctly. It's going to make sure all these other questions are correct, and it'll print out your expected score for the homework. And it looks like I gave you 11 questions instead of 10. So we'll see if I decide to give that as a bonus or if I want to make this out of 11. Regardless, good luck on the homework, and if you have questions, make sure to either email me or leave them as comments. Thanks.